So we've got four vectors up here, u, v, w, and x. We've got the symbols u, v, w, and x with the arrows over top, and we're also representing them with four arrows here. Vectors are equal if they have the same magnitude and the same direction. So when we look at these vectors here, which vectors appear to be equal? Yeah. So we can say that vector u equals vector x. Same magnitude, same direction. Now, if we're just comparing the magnitudes of the vectors, we're just comparing the lengths of those arrows. So if we look at w and x here, those two look to be about the same length. So we can say that the magnitude of w is equal to the magnitude of vector x, okay? Because they have just the same length. Okay? But the vectors themselves are not equivalent because we have to have both the same magnitude and the same direction. Vectors are opposite if they have the same magnitude but opposite directions. So this is illustrated by u and v here. These have the same magnitude, the lengths of the arrows are the same, but they point in opposite directions. So what we can say here is that vector u equals negative v. I've just taken u, I've put it in the opposite direction to give me vector v. But I can also say for these two that the magnitude of u is equal to the magnitude of v, because again, these two vectors have the same length. So they're not equivalent, but their magnitudes are equivalent. Many of the questions that we'll be asked to solve will be given two vectors, and we'll be told that there's some angle between these two vectors. Anytime we're measuring the angle between two vectors, we place them tail to tail. So we'll talk about the two parts of a vector. Basically, the head of the arrow is the tip of the vector, and the end of it without the arrow on it is called the tail of the vector. So it's kind of like an actual arrow, like bow and arrow kind of thing. Tip of the arrow, the tail of the arrow. Okay? If we're talking about the angle between these, we have to move these vectors so that they are tail to tail. So I can take this one over here, I can line them up like that so that they are tail to tail. And that's one of the things about vectors. You can take vectors and you can move them around all you want. Okay? As long as you keep the length the same, and as long as you keep the direction that that arrow is pointing the same, you have the exact same vector. So that vector that I moved over to here it's the same vector as before. So I could label these things. I'll call this vector A. I'll call this one vector B. And let's say the angle in between there is 47 degrees. We would say that the angle between A and B is 47 degrees. Okay, so that's what vectors are, parts of vectors, and sort of how we can talk about their orientation a little bit. Next up, a little bit of some of the arithmetic that we can do with vectors here. So first off, multiplying a vector and a scalar. Okay. So in this case, what we've got is some number k. This is just a number. 3, 7, 22, -8, whatever. And we're multiplying our vector here, v, by that scalar. Okay. What happens to our vector here? Well, if we multiply vector v by k, it changes the magnitude by a factor of k. So if k is 2, it gets twice as long. If k is a third, it gets 1/3 as long. The direction is the same if k is positive, and the direction becomes opposite if k is negative. So let's take a look at an example here. We've got v down here. We'll assume that it has a magnitude of 2. if we want to make, let's say we multiply it by 2, basically what we're doing here is we'll take v here and let's clone this thing. 2v would be like 2 versions of vector b placed tail to tail. So our new vector would be twice as long as our original vector v, but pointing in the same direction. What would the magnitude of this new vector 2v that we've created be? Well, what was the magnitude of original vector v? Yeah, this is going to be 2 times the magnitude of v. The magnitude of v was 2. So the magnitude of my new vector, 2v, is 4. Okay. Parallel vectors. Parallel vectors are vectors that have either the same direction or they have opposite directions. Now, a word that you'll hear me use when they have opposite directions, I'll sometimes refer to them as anti-parallel. Okay? It means that they are parallel, but they go in opposite directions. So all of these three vectors that we see here are parallel. Okay? They all point in the same direction or opposite directions. But if I were to take this one here and this one here, I could also say that they're anti-parallel. Your textbook doesn't use the term anti-parallel, but I might use it when I'm talking in class. Okay. And finally, two vectors are parallel if and only if they are scalar multiples of each other. So if I take one of these vectors up here, let's clone this guy and bring him down here, and I take this guy over here, and we'll clone him. Okay. These two vectors are, I've told you that these things are parallel. That means that there's some factor that I can use that I can multiply the first one by to get the second one. So if this one on the left here is vector A, this one on the right is vector B, B equals some scalar times A. So in this case, the value of B, well, B is just a little bit longer, so it might be something like 1 1/4 times as long as A, just to pick a number there. Okay. So if two vectors are scalar multiples, then they're also parallel. If they're parallel, you can take one, multiply it by some number, and get the other one. Any questions so far? Okay. Unit vector. A unit vector is any vector that has a magnitude equal to 1. Okay? Now you can take any vector that you want and you can turn it into a unit vector by dividing it by its magnitude. Okay? So if you had a vector like v, okay, and the magnitude of v was 2, kind of like in the last example that we did, if we take vector v and divide it by 2, okay, we get the unit vector v. Okay, we divided it in half, so it was originally 2, we divided it in half, now it has a length of 1, so it's a unit vector. And we denote unit vectors by, instead of the regular arrow vector symbol, this little hat over top of them. So sometimes we say that this is a v hat. Okay. And the reason you use unit vectors is sometimes you're only interested in the direction that a vector is pointing. Okay? Vectors have magnitude and direction. If you want to talk about the magnitude, you use this absolute value here, and that gives you that picks out the magnitude of the vector. If you just want to talk about the direction the vector is pointing in, that's when you use the unit vector. Okay? So any vector can be expressed as a product of its magnitude and its unit vector. Okay? So our vector v can be thought of as having magnitude v and direction v hat. Okay. Well, this is telling us the magnitude, and this part over here is telling us the direction. So let's say we have a vector here. We'll call this as our unit vector, v hat here. And we want to make a vector v that has a magnitude of 3. How can we take this unit vector and turn it into vector v that has a magnitude of 3? What do we need to do to our unit vector? Or how many of these unit vectors do we need? And we're going to need 3 of them. So if I take 3 of my unit vectors and I put them one after the other, I have created this new vector that has a magnitude of 3 because my unit vector here has a magnitude of 1. Let's fix that. Magnitude of my unit vector is 1. So we've got 1, 1, 1. So my new vector from here to here is vector v, and the magnitude of vector v is 3. Okay, so I've taken the direction from my unit vector and given it the correct magnitude that I wanted. All right, working with vectors. So this is the big thing that you want to know. The stuff that we've been talking about up till now has just sort of been what are vectors, where do they come from, what do they look like, and things like that. Big thing you want out of this unit is you want to be able to add vectors together when you have them. Okay? So there are 2 ways that we're going to be adding them. We'll be adding them together graphically, and we'll be adding them together algebraically. So if we're adding them graphically, as I've already kind of done in a few examples, we want to place them tip to tail. So if I want to add vector A to vector B, well, I take vector A, I put it down over here, and then I take vector B and I place the tail of vector B on the tip of vector A. And when we add 2 vectors, the result that we get, we often call R, or that stands for the resultant vector. Okay. So our resultant vector runs from the tail of our first vector to the tip of our second vector. So this would be our vector R right there like that. Okay. So we always place them tip to tail, and that little triangle there forms our resultant vector. If we want to subtract 2 vectors, let's say instead we wanted to do vector A minus vector B. Subtracting vectors means adding the opposite vector. So we've got vector B over here, and I've also created another vector which is the opposite of vector B. Opposite just means it has the same magnitude with the opposite direction. And if I'm doing A minus B, that's the same as vector A plus minus vector b. So that's going to be our resultant. So we take, again, we take vector A, we take minus b here, we place them tip to tail, okay, and our resultant goes from the tail of one to the tip of the other. So this would be our resultant vector there. So anytime they ask for the resultant vector, they're getting you to add these two vectors together. Now sometimes a question will ask you for what is called the equilibrant of a vector. Okay. Equilibrant just means a vector that would balance a vector that you're given. So if this is vector r right here that results from subtracting a and b, the equilibrant would be the same vector, but just going in the opposite direction. So it would have the, let's see. So put a little dot there so you can tell the difference between them. This one right here would be vector E, the equilibrant. And it has the same magnitude as R, but it is in the opposite direction. All right, so